Siellä virallisessa osoitteessa tavat julki silleen, että siellä ei ole enää kaunis logo, vaan se liikkuu siellä. Näkyy kentällä. Joo. Itse ajaa sen pitkään siitä. Mitä? Olet ajaa joku pitkään siitä.
Tämä on tämä juttu.
Ajaa sen pitkään läpi. Riittää joku 3,5 kirjaa. Pitkoa sanotaan.
Niin, siis tämä on ajettu juu. Tämmönen linkki löytyy.
Oikein niin hemmetti. Laitan noin kaikki selvä. Niitä on paljon hyvää. Mä edes kirjoittaa tämän hyvin.
No. 2 Y.
2 pieni hyvä.
Joo, pieni Y. 0. Mutta on pienillä kaikki. Y. Sen Ville.
Kun mitään smash
ja V. Ville.
toivottavasti ei tässä enemmän. Jotenkin mä oon
Se ei varmaan Netskopetsi. Se Netskopetsi taas. I think you were
Yeah, I was planning like I wanted to we are found a good opportunities. Some part of CNCF. It's exciting. People will know. For the first one,
ei tarvii enää.
normal.
Let's see how many comes.
Yeah.
It's easy to begin the meetup.
It is. Then you actually have to get out like and go there. So yeah. That's good. So what are you thinking?
Pretty much the same. Sometimes you go for more. There wouldn't be a big step from that.
No, yeah.
At least that's something. So they use like microservices and kind of like scalable systems. Not monolithic systems that like straight to the server.
Yeah. The app gets installed like a package.
6 katsojaa.
Tuli vain Helsinki, ei ole protect. Joo, olen. Joo. Everything is about my computer. So but I
music a bit too loud, you know. I can't hear my thoughts here. Everybody's raving.
yeah. Yeah, that's good. Yeah. That's why I scheduled it to be now. I just found No. Yeah.
Did you do what you put on the truck with some batteries? Or
Yeah.
like lead pumps on a service board?
Onko tää niinku limppari mua varten?
Thank the thing is that you can, privately there is like each or you can see like Arabic or one in that
Barcelona 6.
Sunday. convinced that you're featuring and I like you.
Yeah. So yeah, I'm 180.
Oh, okay.
Yeah, actually,
How did you contribute around whatever what happened?
as soon as yeah, now I'm like thinking of my contract. That's going to be a lot of fun.
Yeah, background in what is this?
It's cool. Kubernetes is basically my first programming like my things out for that. It's like the first thing I can
miles behind them in the industry. They're still very published open source. I'm not good enough.
So basically programming
Very complicated expertise.
I really started at the perfect time because I started at the time where it was kind of like stable enough, like it's not breaking all the time, but it was like still there's a huge like abundance of improvements to be made. So
These have too many existing solutions.
yeah, exactly. Exactly. although I have Raspberry Pi, every mistake, mistakes as well. So you're flying on the gear. So basically, why I announced it in July. I have a company that I'll try to put it on hold for a time. I didn't really think about it back then.
Uskomattoman kuulosta. Tai jotenkin. Niin. Se maksaa. Tavallaan sillä ja jos siinä on noin 5 mies, hän ei ilman
Whether Yeah, could you log into that? Okay, yeah, so do we think we'll...
I tried to open preferences to, remove the $20 now on preferences.
So basically we'll start with this. But I don't know what we want to table is doing with soup, but we'll see.
Yeah, just join with the first think it's good. We just talk loud. What happened with our TV? Yeah, we just should talk loud, but it's pretty good, so.
Do we think it works?
Yep. Okay, well, welcome to first, I have something is looping on. I'm going to probably get fixed, but well, welcome to first Kubernetes Finland meetup. And I hope that you will enjoy. Please, Lucas, now continue. So
Yeah, we'll see. A warm welcome from me as well. I'm happy that you're here. And this is, as you know, the first meetup in Finland. We're really excited about starting up a community here as well for CNCF and Kubernetes and related projects. And yeah, just a quick, where is CNCF and Kubernetes meetups in the world today? They are pretty widespread all over the globe. CNCF wants to connect with all meetups that is CNCF and Kubernetes related, and has had great success so far. And yeah, we're thankful to have CNCF as one of the sponsors for this meetup. And I'll get into what CNCF and Kubernetes is later in my talk. So who am I? I'm Lucas Kjellström, and I'm an upper secondary school student, lukiolainen in Finnish. And I just turned 18. I'm a CNCF ambassador, so hence I'm driving this meetup thing. And recently also became a Kubernetes certified administrator. I really recommend that once you have your hands dirty with Kubernetes, you take this course, and it will give you some badges and cool stuff, like you can show a diploma. And also, I've spoken at KubeCon Berlin about something, and I'm going to speak at KubeCon Austin later this year. I've been into Kubernetes stuff for about 2 years, and I'm a maintainer now as well. And yeah, I'm driving, beside upper secondary school, I'm driving a company for myself that performs contracting for Kubernetes open source work, basically. So yeah, that's me. Do we have Annie here as well?
Yes, I'm here. Yes, let's grab the mic. So, hi everyone, my name is Annie, and as you can tell from the slide probably, I work for UpCloud. So if you're wondering where you are, this is our office, welcome. I hope everyone got some pizza and Coca-Cola or whatever drink you want. So I work for UpCloud, and I manage events and community, so this is obviously a cool thing for me. And then we are an infrastructure as a service company, so we provide the cloud that you guys can build applications on top. And then we do have the world's fastest cloud servers, and that is not a joke, that is not an exaggeration, we actually have them. And we have tested it, and you guys can test it as well. And if you want to know more about that, you can always ask the UpCloud guys who are here. So me or the UpCloud people, raise your hand and wave it or something like that. They are super friendly, awesome. You can just chit chat with them. And we do have globally data centers in Helsinki, Singapore, Frankfurt, Chicago, London, Amsterdam, and so forth. So it's a good coverage, and this is our headquarters, so very much a welcome and have a great evening.
Okay. Well, yeah, then there is my my introduction to me, but no worries, because I'm talking more, so I will probably tell something more about myself later. But now you can see me as a tabula rasa or something like that. Very blank one. Okay, I think next one is going to be
Yeah,
who?
me.
You.
Yeah.
That's cool. Let's find out where we can find your slides. This one.
Yeah.
Here we go.
Did you reload the Zoom?
Nope. Let's go.
Okay. So my presentation is like an introduction for you. This is the first time, as we said. What is cloud native? I mean, as with all like buzzwords like big data or just cloud or cloud native in this context. Do you have it?
help you a little.
Yeah. Okay. Yeah, that works for me as well.
Put it up.
Okay. There we go. Yeah. So you can follow in the if you want to see the slides, you can follow that bit.ly link as well. And we have this really amazing picture of Kubernetes with Gophers as Kubernetes is written in Go. Yeah, so I'm well, this is only going to take a half an hour, and I'm going to try to squeeze as much content as I just can into this, so you get a lot of context, like what is this thing, why does it matter, and basically why are we all here today. Yeah, Cloud Native Computing Foundation is a non-profit foundation for that was founded with Kubernetes as a seed project. They basically care about open source computing for applications. And the for applications here is very important. It's not for infrastructure per se. It's about your application. How do we deploy them, like DevOps pipelines, microservices, service meshes, and orchestration, monitoring, all these different aspects of modern applications that they need. Here we have the CNCF landscape, which the executive director and other employees of CNCF produce. Basically, we have these different areas with like public clouds, like container runtimes or storage solutions, network solutions, orchestration, service meshes, platforms, data analytics, everything. And here they're trying to visualize that like we have a lot of projects, both open source and closed source. Who can we trust? Well, if we have this vast amount of possibilities to choose between, who do we know? How do we know that, well, this is a good project or this one? Like, how can we know that? And that's why CNCF basically was established, to promote and to like curate a trusted set of projects that you can you know that they are really high quality. CNCF has some of the tech industry's top experts and architects, the technical oversight committee that votes on like should this project go into CNCF, should it be a CNCF project or not. And this makes it easier for you to like know that Core DNS is a project you can trust. It's well maintained. It has like a good plan, like how roadmap, and like Kubernetes, one of the world's largest open source projects, etc. So this is you can read more about the landscape in these various links as well. And this presentation is going to be available to all of you later on. So again, what is CNCF? It is a non-profit foundation under the Linux Foundation. And it was founded pretty recently in like today's terms, and basically has this, promotes these projects, create this set, and help projects to succeed. Like if they need basically why are we here today? This is a CNCF event, and they help organizing them. They host KubeCon, recently PromCon for Prometheus, and all these cloud native con as well. And yeah, basically we have a neutral place to come together. There are, as we'll see later, there are the world's biggest companies are in CNCF, and they work side by side to make open source better. And they do this, and it's CNCF that owns the intellectual property. So we know that it's safe. We're not like it doesn't belong. Kubernetes, for example, doesn't belong to one single company. Instead, it belongs to the world with the Linux Foundation. So currently there are 12 projects in CNCF. We have like Kubernetes for orchestration, Prometheus for monitoring, maybe the most well-known. Docker recently made Containerd as its more lightweight container runtime. We have CNI for like a container network interface. Recently, CNCF also voted to include Envoy and Jaeger. So these are high quality projects that you can feel confident about using in production. Here we have the CNCF Platinum members, and well, you see it's some of the most well-known companies in the world. They all like are dedicated to making open source software, CNCF software better by like allocating their developers to improve developers and other like employees to make these things better. A quick like this slide is from a CNCF presentation. Basically, it tells us like from where did we come. Well, first we had hardware, really like you installed the thing on your box and you had no virtualization or something like that. Then we discovered like, oh, we can virtualize things. Then we had like infrastructure as a service with AWS, for example. Then we came to like platform as a service, a higher level abstraction that many people liked. But then the open source variant of these two things came along with OpenStack and Cloud Foundry, which are greatly valued projects today as well. And suddenly from like nowhere, Docker came and popularized containers, which basically had been a thing with LXC and C groups and all these kernel low-level things, but it wasn't user-friendly, so not many people used them. Like Google used them for a long time, but they weren't like widely used. So then we shifted to cloud native, which are kind of, it's a like buzzword, but applications are born in the cloud. Some people like to say. And what is this cloud native mindset then? Well, basically it should be containerized. I'm like, as I don't have unlimited with time, I'm not going into like how containerization works or like Docker, but anyway, dynamically orchestrated. This is basic. This can be done with Kubernetes. This can be done with another orchestration as well. But anyway, they should basically float around in the nodes of your cluster, not be like tied to one single machine. And microservice oriented. Many of us are like tired of monoliths, so we have discovered this microservice thing, which, well, might or might not be better depending on your use case, maybe. But there are great benefits with using microservices, although they might be a bit hard to get right in the first place. So to summarize, we can say cloud native is about three things. Speed, like we want things, when we load a Google page, we want it instantly. When we watch Netflix, we don't want to like wait 10 minutes before we can start watching the video. We want it to go fast, and the demands are even higher with every day. especially with e-commerce and these things, it's getting like you basically lose money if you're not fast enough. Freedom, we don't want vendor lock-in. So basically, like if you did choose Amazon and you found out later that you wanted to migrate to Google or migrate to UpCloud, then you should be able to do so, and you should be able to do so easily. So how can we do this? I mean, if we're basically locking in on one single vendor's applications and like services, we can't move this. We can't move the applications easily. But if we have a standardized tool set like Kubernetes and service meshes and things like that, it's much easier because you're not locked in to one single vendor, and you can have the freedom to choose. Also, you have the freedom to choose between all these projects, but you have a better view of who of them are trusted, and which brings us to point 3, trust. Which project can we trust? Which ones are well maintained, and so forth. And we have a good keynote on this in KubeCon Berlin as well by Alexis Richardson. So over to Kubernetes, the most exciting stuff, right? And everyone wants to know what does it mean. It's Greek for pilot or helmsman of a ship, which pretty accurately describes what Kubernetes does. And it's basically Kubernetes steers your data center or your clusters, and so you don't have to wake up 3 a.m. and notice that, oh shit, I got a lot of users at nighttime, my local time, and I have to scale up my applications. I have to deploy more servers and well, whatever. So Kubernetes can handle that for you. You just say what do you want Kubernetes to do, and it will reconcile with controller loops and do that for you. So basically, a one-liner description would be a production grade. It's used in production by many companies, as we'll see later. Many of them are Fortune 500, and these kinds of are actually using it heavily in production. Container, well, we use containers. It's built on containers. Today you can use virtual machines or whatever as well if you implement the right interfaces, but anyway, it's mostly about containers. Orchestration, it will orchestrate your application. You say, how should my application be connected to each other? Applications be connected to each other, and Kubernetes will put the applications on the machines in the best possible way, with resource allocation and bin packing, scheduling, a lot of factors. And yeah, that's basically it. It's Google grown. Google today has 2 main projects they are running in production that is similar to Kubernetes. They don't share any source code, but they share the same concepts. Basically, Google wanted to start a third version of their 2 earlier ones, and this became Kubernetes. So it's basically the third revision of what Google has inside of their cloud and inside of their data centers, but it's in the open. It's a collaborative project, and everyone can get involved and improve it. Even high schoolers or upper secondary schoolers, right? Well, Google has done this for over 10 years, and as we know, it works pretty well, right? They had a report that this was 2 years ago, I think. They spawned 2 billion containers a week, which is pretty good. I mean, it's more than many of us have. Created by 3 Google employees during the summer of 2014. and it has now grown exponentially and was the seed project to the CNCF. The first version was released 1 year after its initial announcement, version 1.01, and since then, basically every new Kubernetes version has come with a 3-month interval. And now, a week ago, even less maybe, Kubernetes 1.8 was released, which was a mostly stabilization release, but that's really important for customers. But there were new exciting stuff as well. I decided I can't dive into what new features there are in Kubernetes. It's more fair to describe what Kubernetes is first, instead of describing the delta between 1.7 and 1.8. But I mean, if you're interested, come after this talk and ask me. I'll be more than happy to share that with you. So what is the point of Kubernetes? Why does it exist? Why do you even need this thing? Well, you probably want to think about your, say you have 1,000 machines, then it's pretty painful if you're gonna SSH into each and every one of these and install your applications, then go to machine 2, install these, and then before you have installed all applications on all 1,000, something probably broke in machine 50 or something like that. So it's doing large scale deployments is basically not working. So what Kubernetes does is you install Kubernetes on every machine, and then you can treat your cluster as a single entity. And you can basically say to Kubernetes, I want this web application. It should have 5 replicas running in parallel. It can be anywhere in the cluster. It should always be up. Then if it gets a lot of users, it should scale up itself to 100 replicas or so, depending on usage. Zalando has even auto scaling based on nodes. So let's say you have a not so busy evening, then you may have 300 nodes. Then the usage increases, and Kubernetes will scale up your applications. It will automatically provision, you will have something that provisions nodes and adds them to Kubernetes, and then you can have 1,000 of services or web applications running in your cluster. You don't even have to wake up 3 a.m. to do that. It just works. So the principle is manage your applications like cattle, bulk operations, treat your applications as templates, and then let something else actually create them and destroy them on demand, etc. Instead of going and treating every single instance of your application as your best friend or something, as your pet. So you should see these as cattle with this analogy. Kubernetes is basically the Linux for distributed system. Some say the Linux for the cloud. We can call it something like that. Well, in the same manner as Linux abstracts away the hardware, we don't have to syscall different syscalls per whatever CPU type, whether it's Intel or AMD or something like that. We can actually have a unified interface how to talk to Kubernetes, and then it will spin up these applications for you automatically. So the important key takeaway here is you declare the desired state of the cluster, and Kubernetes will do everything it can to make what you said it should be the actual state. This is what Kubernetes is all about. And if you want this kind of automation, well, you're in the right meetup. So here we have a couple of Kubernetes users. There are way more than these, but these are case studies on the Kubernetes website. You can just go to Kubernetes.io and click on these and see like what they thought about Kubernetes, why they're using it, what benefits it gives them, yeah, things like that. Then it's a newly started project, but it has kind of gained traction. This is, well, 5 years back, yes. And Dan Cohn, executive director of the CNCF, measured Kubernetes popularity in, and taking different aspects into account. And he wrote 2 blog posts actually about that. And yeah, you can see these slides afterwards as well. My plan has been to like aggregate many links into one presentation, add pretty much detail in some places, and go over them like briefly now in the interest of time. So, well, what does it look like? There are, well, a lot of a lot of users and a lot of contributors all around. Like 60,000 commits just the latest year. Is pretty good velocity to the project. We now have 25,000 individuals on LinkedIn that tag themselves with some kind of Kubernetes expertise. This has like exponentially grown. A lot of jobs as well. In 3 months ago, which might be interesting to you, 3 months ago, a free course, an introduction to Kubernetes and its concepts, was released on the EDX, and now over 11,000 have enrolled this course. Many of them, like I, also like completed it and got the certificate that you like could do it, and it's a really good interactive like description of what Kubernetes is and how you can use it, the most like the core concepts of it, and I strongly recommend that one. We have a lot of over 2,000 unique authors, contributors to the project, etc. So a bit like briefly on the architecture. We have one master or many masters. Many masters is of course more challenging than one master, but anyway, the basic primitive of Kubernetes is the main point is the API server, and basically everything goes through the API server. Then we have a backing database, which currently is etcd from CoreOS, which is a single source of truth. You can cluster etcd. It's basically a key value store. Then we have the controller manager. So you basically say something. You're as the admin, the user. Say that, well, I want 3 instances of my web service, and then that is posted to the API server. It goes into etcd. Then the controller manager looks like, or actually the scheduler goes and checks, oh, we have 3 pods. I'm going to go into what a pod is, that aren't running. Then it will bind this workload to a node, which we have here. In this case, maybe 1 instance per node will be scheduled, and the kubelet will notice that, oh, I got a pod assigned to me, and I'm going to then say to Docker or whatever you have as the container runtime to run this thing. And we also have a networking layer. This is a brief like introduction to the architecture. Is there any questions so far, by the way? Okay. So I'm not gonna read this out now. I'm instead gonna explain them with some images, but this is for reference, like if you look at the slideshow later. Let's think of the cluster as some kind of boundary, and then we have different, in this case, 3 nodes. We say that, well, I want my red application. I want 4 instances of my red application. Kubernetes then goes ahead and schedules these pods, these atomic instances of my template on node 1 and 2 replicas each. And then we have the concept of a service, which basically is like a load balancing algorithm. So if you want traffic to your site, for example, KubernetesFinland.com, our ghost blog is run on Kubernetes. Then if it comes some traffic from here, it will load balance to the pods in order. And let's say the beauty with Kubernetes comes when, let's say, node 1 goes down, a power outage or something. Then Kubernetes will notice that, oh, I'm not running 4 of the red pods as I should. Then I'm going to reschedule these to the other ones, or to more nodes that are in the cluster. I'm not running enough of the yellow pods. I'm going to reschedule that one as well, and the same thing for the green. And so that means that pods come and go. The service is a stable identity for the lifetime of your application. So you can specify, like you can talk to Kubernetes using YAML files or JSON files. There are also a lot of new projects in this area that make it easier. Like, for example, if you're looking for something like apt-get for Kubernetes, you should take a look at Helm. You can do Helm install Nginx or Helm install whatever application here. That will provide some like best practice applications for you, application manifests, and install them to your cluster. But this is basically the way to talk to Kubernetes. A deployment basically has a pod template, like a template. How should one instance, what should one instance look like? And then a replicas field. This is basically what a deployment is. And when you then, Kubernetes will make sure that the replica amount is all the time the same. And in this case, we run one container, Nginx, and it exposes the port 80. And everything is labeled in Kubernetes. So here we have the labels app web app, for example, and then we match that with our service, and our service provides the load balancing for us with a stable IP in the cluster. And sorry if I have to go quickly through all this. Well, we have to do that this time. But what can you? So then, if you want to upgrade to a new Nginx version, you'll just say that to Kubernetes and reapply the manifest. Then Kubernetes will, behind the scenes, do a rolling upgrade for you. So basically, it will scale down the first version here to 2 instances. Then it will then deploy the new one, the new version of the template here, and scale that up to 1. It will then take one from the old one away and create a new one as we go, a rolling upgrade. This is done automatically. Or you can do something like blue-green deployments, where you have like 2 totally different versions of your application running side by side, and then use the service to like switch, should I send traffic here or should I send traffic there? That is also a possibility. There's a lot of, Kubernetes is a so huge project, and you can do a lot of things with it. So it doesn't fit in a single talk. So if you want to try Kubernetes out, you can do so in your browser. Play with Kubernetes is one example. If you want to run it on your Mac, for example, you can download Minikube. if you have some machines on UpCloud or whatever, you can use kubeadm, which you basically apt-get install kubeadm, and then kubeadm init. We'll see this later. If you have AWS credentials already and things like that, you can use kops to create a cluster. Or if you don't want to think about nodes or anything, you can use Google's hosted Kubernetes service for you on Google Container Engine. Well, you basically outsource the problem of running Kubernetes to Google and run all your applications there. Also, we have a cool project called Kubicorn, which also is able to do Kubernetes installs, and this is a large area as well. So these are just some good examples of how you can run Kubernetes. Here is an example. Basically, this is a disclaimer as well. I mean, I'm working on kubeadm as well, and it's a great way of deploying Kubernetes if you want to run your, want to customize your solutions or build it basically from scratch, but anyway get a lot of functionality for free. You basically run one command, which is kubeadm init, and kubeadm will then create this cluster for you. It will set up the API server, etcd if you want, so controller manager, all these components will just be there for you. And then you install a networking layer, an overlay network in the cluster that will connect all nodes with each other with IP tables or whatever. And then when you have your second node, you will just, kubeadm init will output a token for you. So you then just use that token as a way to authenticate to the master. And well, you now have two nodes in your cluster. And just to show, these are the high-level features from the Kubernetes IO site that really describe as briefly as it gets some of the core features. We have way many features than this, and it's also a problem. Kubernetes might be a bit hard to learn. I mean, it has sometimes a steep learning curve, but it's really worth it because it has a lot of features and is really production ready, and is one of the best solutions out there. So that was just an example. So how is this code and all things, features, how are they organized? Well, basically we have special interest groups that focus on some areas. For example, like cluster lifecycle, I'm working, and Alexander, in that SIG. Or we have one SIG for applications, how do we run them smoothly? Or well, we should actually do a release now every quarter. We should have a SIG for coordinating that work between all the other SIGs. Yesterday, the vote for the steering committee closed. So soon we'll have a steering committee which will guide the project as on a high level, where are we going, what should we look into. But this is hopefully not a technical, it's more like a people and organizational thing. Most work will be done in SIGs. Then we also have work groups that specialize on it can be narrow, or it can be SIG, things that are spread around SIGs. And cloud SIGs for different cloud providers, etc. So next steps. We're about to round up here. You can follow the Kubernetes blog. There's a lot of great content there. YouTube channel. All these SIG meetings are basically recorded. They are public. Anyone can join on Zoom. Most of these SIGs have weekly meetings. You can also watch these meetings later. There's a Twitter feed. You can take this Introduction to Kubernetes course. I highly recommend it. You should definitely get in touch with us on Slack. I'm Luxus on Slack. as well. You can take the Certified Kubernetes Administrator exam once you're acquainted with most concepts and feel confident about like running Kubernetes in production, or like also for development. And you can join a special interest group. That's basically the best way to get acquainted with the project. You can use Minikube or KubeADM to create a cluster. We have weekly community meetings. If you want to read a really in-depth 150-page long or something like that analysis of the ecosystem and like where Kubernetes is going and all this, I highly recommend the new ebook, The Kubernetes Ecosystem, by the New Stack. And yeah, so KubeCon, Cloud Native Con in Austin is in December, the 6th December to the 8th. And this time there were over 900 proposals for speaking, which is like, this really tells something. There were 400 to Berlin earlier in March. More than half a year later, we have 900. We expect about 3,000 attendees to Austin. And yeah, then if you don't want to go to Austin or don't have time, we know it's Finland's 100th birthday at that time as well. You may want to consider coming to Copenhagen in May 2017. 18. Well, copy paste. And yeah, that's coming then. And yeah, we also have a short promo video for KubeCon. Let's see if we can get that working. Doesn't seem so. I'm not sure on which screen it went now. Do you know?
No idea. No, well, something's happening.
It may just be a little bit slow if we're on Zoom. Oh, well.
No
it went for 40 minutes.
No, but we have upgraded it, so no worries.
Have you?
Well, I think we should just post a link somewhere.
Yeah.
Yeah, if it doesn't work. Well,
Okay.
Did you have any slides after that?
no.
Okay, well
That
then it's good.
It was the last thing.
Okay.
Yeah.
So,
So we will now have a small break. So before demo session, I
Yeah.
think.
Yep.
So grab a drink, or there's a couple of slices of pizza still left, and stretch your legs a bit and get ready for the
Yeah, eat the cold pizza is the best.
Yeah.
Yeah, food. Yeah, thanks. So let's see. We have upgraded it. It send me like, hey, this is trial version. For one time, you will get unlimited minutes. I'm like, well, what happens if we unlimited minutes for this session? So don't close it. Don't close it.
yeah, cool.
Ever, never.
Yeah, you're gonna have it running.
Yeah. It's very.
Okay.
But now I think. Oh well.
That was-
I think.
Yeah, close. I mean, I made it
Well,
basically on the
Okay, I hope the internet will hear me too. Again, welcome. And well, today I'm going to speak about serverless on top of the Kubernetes. So this title is it can be pretty much confusing if you're thinking that we're talking about running Kubernetes as serverless. No, we're not doing that. I'm not sure if that would be stupid or not. Maybe it's genius. Well, however, I'm Teemu, and I come from a company called Emblika. It's hard to pronounce in Finnish and English. It's also hard to write. I have seen lots of different variations about it. Like sometimes it's B, sometimes P, or C or K, whatever. However, we're super small. We're just five people, and we're consulting about data engineering, DevOps, and sometimes a little bit machine learning stuff. And well, we have mostly our customers are like startups. There is some mid-sized companies, but also enterprises like Sanoma or Ottawa Media, or let's call CGI. And well, currently we are working with Kubernetes and Docker and Ansible and that kind of stuff. I'm going to start this with a lesson about history of DevOps. And this one is a little bit opinionated version. Have you seen this one? Yeah, you should. This was the idea of DevOps, that there is just one team that can deliver the application from their own laptops to servers running in the cloud. And it was a pretty nice idea, but this was the implementation. So they are going to hire some specialists called DevOps guys, and and then they are responsible for full deployment. They are doing everything. They're doing infrastructure, they are connecting cables, they are configuring Jenkins, and well, yeah, it's cool. Like those Supermans. Everybody loves them, and probably that's the reason why they are so expensive guys to hire and hard to hire too. So there must be a guy who knows the infrastructure and also knows some software development. Pretty hard, I could say. I'm going to introduce you a new ideology today. It's called, DevOps. But let's color it green, so it's different DevOps. Well, it will be actually pretty much the same, but this one is added. So operations team, there is still ops. They have to maintain the platform where the DevOps, or actually the whole team, can deploy on. And now when we are here in Kubernetes meetup, I could probably say that the platform will be the Kubernetes. So in future, there will be the ops team doing the infrastructure and maintaining the platform, Kubernetes, and then the whole team can deploy on it. And it works then. I believe so. Or then we have just more of these guys and, well, no, these guys, and then everything's fine. It's like previously. Well, however, we are talking about serverless today. And what I mean, I probably have to define it. Because mostly serverless is using servers, if some doesn't know. And well, if we want to define it a little bit better, probably should think about what does the serverless offer you. And well, it removes things. It removes need for these guys. Provisioning, operations, scaling, no more availability problems. That's all what serverless does. But actually, when I was thinking about this, it's the similar that Lucas here promised that Kubernetes does. And well, so there is not so much difference then. Well, do you remember this? It's PHP. It's beautiful. It's microservice. It tells you your IP address. Really, it's microservice. And well, you know how these kind of microservices were deployed? AirSync, SSH, Vim, anyone? Yeah, it's the way how you deploy this kind of microservices. But well, now when we have the Kubernetes stuff, things get simpler. We have to just build an image, push it to the registry, make some manifests, and push them to Kubernetes. And then it's just like that. Well, maybe we still have a need for deploying software more easy. And well, this is what the serverless might be for Kubernetes. It's more agile. And then there is another thing that kind of the PHP microservice serverless platform did. It's running, not all the time, but when the user issues a request or some other event or action to start the service, and then it does something and it shuts down. And that's the point. It's like on demand. Well, currently when we are creating some Node.js services, they're running all the time and they're consuming resources, memory and, well, some other space. And then we probably have a problem with that in some point if we have lots of those microservices doing important stuff, like telling the IP address. So probably it's not game changer, but we still can have some point with that. Well, then we can think about why we use Kubernetes on top of serverless. We used to have the PHP stuff going on. Well, first of all, the operations team that I just told that they are going to maintain the Kubernetes, they don't want to maintain any other system anymore. Trust me. Well, then Kubernetes actually offers pretty good environment for keeping stuff around the serverless stuff and other containers that are going on, like databases, and it has some scheduling system that if somebody will break your server, it's going to redeploy it somewhere else. And it has some other cool services too. There is some networking, and probably people will develop more stuff on top of the Kubernetes. So I think it's something that we can rely on in the future, that somebody is going to maintain Kubernetes, somebody is going to develop it further.
That's what they said about PHP.
Yeah, well, that's true, but I think there is now, tell somebody, what's the current version of PHP? Somebody knows?
7 something.
Okay, so they did. So let's go into serverless on top of the Kubernetes. Currently, I could Google these guys, their logos, and they're also projects on top of the Kubernetes, except the OpenWhisk, which is more like general serverless platform. It's originally created by IBM, so it must be very good. And well, I haven't used it or tried it yet, but I think it has lots of stuff in it. And well, then there is the other projects. They are a little bit smaller. The Kubernetes is probably good. I've tried it once. Worked well. Function, never tried. And Fission, we're going to demo about that. So let's start demo time, or maybe demo effect time. So let's see what happens. Oh, you can see nothing yet. Let's see if the mirroring works. Yes, it does. Okay, here we go. I'm not cheating. Okay, so let's first start with the text editor. This one is the today's version of PHP microservice. It's made with Node.js. It's the language from the future. And it will send out for the response, it will send hello Kubernetes. I'm not going through the installation of Fission, but you can read it from the interwebs. And after that, you have some pods, as you can see here. So it will create lots of stuff running on your Kubernetes, and it will orchestrate everything. And now I'm going to show first how I'm using it as a user. And then after that, I'm going through like what happens behind the scenes. So here is my function or my microservice or my serverless Lambda function or something, whatever you want to call it. And here is my cheat sheet. First, let's create environment. So with this Fission project, you have to have some environment for running those. So if you're using Node.js, you probably want to have Node.js environment, or if you want to have PHP, then you need PHP environment and so on. So we're using the Node.js environment from the Fission project, and I will later show you how it's created, and you will be, it's horrific. Well, let's create it first. Wait a minute. Here, more space. So here we go, and we create it. Ta-da! What happens now is that the Fission will download something from the Docker registry and pull something running. But still, if we go into this URL, not this one, this here, nothing found, and here, nothing found yet. Okay, 404, page not found. Let's deploy the hello.js, which look like this. Again, we are going to copy paste some cheat sheet stuff. And here what happens is that we create function called hello. It uses environment Node.js. It's uploading hello.js, and it binds it to URL hello with HTTP method get. Let's try it out. It worked. And now, let's hope. Hello, Kubernetes. Okay. Well, clearly we have here spelling mistake, so we need to fix it. Let's open it again and fix it. And then probably we would like to have some counter. You see how good I'm coding. So let's make global variable. It's always good with serverless stuff. And let's start it, or let's update it. And again, I'm going to just copy paste it so I don't have to write it. So here we have another command, Fission fn function update. We are referring to the old function name, and we are just uploading the same file again. Let's see what happens. Well, it's already there. I didn't have to build some containers. And if you actually go into that address, you should be able to send me more numbers. Okay. This works fine, but what if we have a little bit more complicated software? Let's make API that provides us user-submitted questions. And here we have it created with Python. We have 3 files. So let's see. This one is, first the API. This one connects to Redis database. And actually, I created already the Redis database with this old and fancy Kubernetes manifest that takes like 100 lines. And after that, I can refer it inside of the Kubernetes cluster. As Lucas showed you, the networking stuff then manages out how to connect there. And from here, from from the actual code, we can just refer it as hostname.redis.questions. Let's see if this works. I think there is already something in the Redis. I hope it's not something I don't want to show in the publicly, but let's try it out. So first, once again, we are using Python environment because now we're deploying Python. Here we go. Then we are creating first function. Let's say we want to have the questions API here. Okay, and now let's see. This was page not found. Now we have fancy API. Okay, well, not so bad as I thought. So here we have some stuff going from the Redis database, but we still can't have any way to add more things. So let's create more functions. It's always good. We had the add question function that I can show it for you. This one is just taking from the body, from the request body, some stuff and push it to Redis. Okay, let's try it out. Okay, we can't test this yet. Well, we could, but we don't want because we want to create some fancy user interface for that. So we have this function that creates a form. So let's copy paste more stuff. It's the first one. And here we go. Send questions, and let's see. Yeah, there it is. And now we can send some stuff. And I think now it's supposed to be here. But once again, we have problems with our code. We have here some nasty white spaces. Let's see it from the form. Oh yeah, can't do any HTML. Okay, we update it. I want to update with this. And now I think if we send some more stuff. Hello. We can probably find it from here. Okay, there it is. That's how the fission and the serverless stuff works. Like, that's how you deploy software, like in the old days. Except probably the Redis manifest, but you didn't have Redis in the old days, so it doesn't matter. Well, let's get back to where we were. So here we go. I'm curious if it works. Well, probably it works in the internet still. So how it works, and now we're talking about the fission. There is a pod or there is a service called Pool Manager, and the Pool Manager will create generic environment pods. It will make a little pool of those. So the generic environment pod actually consists very, very simple servers made with those languages, made with those environments. At least with Node.js and, for example, Python. Then, when we are issuing new command, some event, for example, HTTP request to router, the router will ask from storage layer or from the managing layer that please specialize me some pod. And so the API specializes one pod from the generic pod pool, and it injects the code inside of the pool, and after that it can answer for the requests. The router can be it can span on HTTP request, but it can also span probably some timer events or like scheduled events, or it can read some stream, or it can ask some jobs from some queue. There is lots of options even with this one. And what happens in the code level, this one is from the Python environment. So first, when the request comes or new function comes in, it will happen the specialized step, and it will actually just call one endpoint, HTTP endpoint, and specialize it. And here you can see that actually it posts some data, and then the then the actual implementation, which holds the serverless function, will inject inside of one variable and will define it. And then when the request comes, there will be the app root, which actually evaluates the user function. So it works like this. It's not magic, but I think it's pretty ugly way of doing this. They are going in the future. With Fission project, they are going to change this a little bit. For example, the current environment implementation, it's not very good for compiled stuff. So if you are writing something with Go, then there isn't any build pipelines or something like that, and it might be hard to get into the container. But well, there is already Go runtime. It's just not very beautiful. With Fission, you will get very fast cold start, and you don't need to hustle with the image management. But then there is lots of problems still. For example, one file is currently only supported option. You can't just push some folder like with some cloud providers, like Amazon Lambda. You can send the whole zip package, and you can't add your custom dependencies. If you want to have some custom dependencies that are not already in the environment, you have to build your own environment. And well, I think that a little bit like it's it's not something you want. Then one thing that people would likely to have is some on-demand running on normal containers, normal images. You want to have your own container without this weird specializing stuff going on. You probably would like to have it to run only when there is something happening on demand. And well, currently this can't do that. If it can in the future, I will write that one. So then some new project that you can find from .io domain will do that. So take care. Okay, thank you, and thanks for listening. I hope you enjoyed, and if you have any questions, please ask. Any questions?
Are these slides going to be available as well?
Yeah, and actually the whole stream will be also available from the YouTube. So, but yeah, I think I will make these slides available too. Other questions? Yeah.
If you do something stupid on your function, can you break the whole runtime that's running other functions as well?
Well, the short answer is yes. Longer answer is no, because pretty quickly the runtime will fix itself because it's going to restart. But yeah, currently there is a problem that if your code contains, let's say, a syntax error, and it injects it in, and then it can't evaluate it, it will just shut down and it will tell you infernal server error, and that's all. Yeah. So in the future, they are planning with the Fission project that they are going to support some checks before running. Like with compiled languages, if it compiles, it works. But with with the other languages, you can probably try to sandbox or something like that.
So that will affect for the fast start?
Well, yes and no. It's going to be, the check's going to be before it's deployed. So in the deployment step, when you're actually pushing the code, it will do those checks, and after that, when it's running, it will just start. Yeah, so it will work normally. Yeah.
Have you used this in any real cases, like with customers?
No, not currently. We don't have any of those in production. we're just testing it out. I think it's not yet production ready for various reasons. Yeah. But
follow-up question: is there like nice tools for continuous like integrations or like deploying the only functions? Let's say I have a repo with multiple functions and so on.
Not yet. Not yet. The tooling consists now currently only the Fission tool. It has some, but mostly those are for managing the stuff. So you can delete or list or something like that. But for deployments, it's pretty lightweight. So only one at a time. Of course, you can use the bash and do stuff like in the old days. Yeah. Okay. Well, if not anything else, I think we will have a short break, and after that,
We can actually ask you guys, do you want to have a short break and grab a drink, or are you good to continue?
nodding means yes.
How many wants to continue straight away? Raise your hand.
Let's have a break. Okay.
Couple of minutes and
Couple of
grab
minutes.
a new drink. And
Yep.
whatnot.
Seuraava Chalando-homma. Itse asiassa täältä me nähdään YouTube-striimistä. Mä sen ottaa.
Oletteko te kokeillut mitään muuta niistä kuin sitä Fissionia?
Joo, mä oon sitä Kubelesia kanssa testannut ja itse asiassa tuntuu, että ehkä se Kubeles on vähän parempi. Mutta siis molemmat noista on mun mielestä vähän liian himmeleitä. Edelleen niissä on tosi paljon niinku turhia komponentteja ja sit mua pikkasen häiritsee toi toteutus. Mä voin itse asiassa näyttää, se on tässä auki. Niin.
Skippasit netin sitten Fission asentamisen, että kun ei ruskainen operaatio.
No siis ei, se on itse asiassa Helmin kanssa on aika silleen play. Että kyllä toi niinku on aika easy homma. Siis täällä on niinku, tässä on se koko esimerkiksi Node.js-serveri, jos on tuttu. Niin tää on ihan normaali serveri, mutta sitten täällä on specialize route ja sitten täällä on tämmönen, mikä vaan ajetaan täältä. Tää on vähän silleen nästi, mutta siis silleen, että environment-toteutus on 124 riviä. Et tavallaan niinku se on ihan fine. Ja sit pystyt aika helposti auditoimaan, että mitä hemmettiä tapahtuu siellä sun systeemissä. Tai sä voit lähettää esimerkiksi, jos sä teet oman, jos on niinku oma käyttötarkoitus, vaikka sisäiseen käyttöön, niin on tosi helppo sitten tehdä ihan omanlainen environmentti. Siellä voi olla tosi paljon vaikka analytiikkaa ja tämmöiseen liittyvää kamaa sit välissä, mikä helpottaa ja sit saa vähän semmoista. Ja sinänsä niinku, on toi varmaan muuten ihan production grade kamaa, mutta kyllä silloin tällöin mua vähän niinku mietityttää. Sitten tuolta puuttuu esimerkiksi niinku namespaceaus eri niinku projektien välillä. Et kun sä teet tommosen niinku pelkästään noista serverless-funktioista muodostetun backerin, niin sit sä et kyllä välttämättä halua, että ne on niinku silleen kaikki samassa. Nytkin mä oon tehnyt tuolla Kubernetesen ingressillä sit sen, että eri funktiot menee eri paikkoihin. Sitten niille voi laittaa vähän namespacea niinku sitä kautta, mutta on se vähän hankalaa. Niinku ei tää nyt niinku ihan täydellistä vielä ole, mutta ihan hyvää suuntaan menossa. Ja siis se on ehkä tärkeämpi olisi mun mielestä se, että saisi silleen on demand luotua jonkun podin pystyyn tai skaalattua ilman, koska tällä hetkellä esimerkiksi Kubernetesen autoskaalaus toimii niin siihen, että se perustuu CPUn käyttöön. No jos sulla ei ole mitään vastaanottamassa requesteja, niin voin kertoa, että CPUn käyttö on tasan 0. Se ei paljon auta siinä. Niin se olisi itse asiassa aika helppokin ehkä nimenomaan sillä autoskaalauksella. Jos tulee requesti, niin spinnaa yksi pappu pystyy sinne. Ja tossakin toimii nyt jo tietyllä tasolla tuo autoskaalaaminen silleen, että sit jos requesteja alkaa tulee lisää, niin Kubernetes kyllä sit puskee sinne enemmän pannua pystyyn. Ja siis tosi hyvin skaalautuva kyllä. Testattiin, iskettiin niinku vähän kuormaa, niin kyllä toi toimii aika hyvin toi serverless-puolikin. Sitten on semmosia asioita, missä sä et halua ylläpitää mitään serveriä, niin toi on ihan näppärä.
Sehän on tavallaan yksi tapa tehdä serverlessiä sille, että joka requestiin podcastaa Docker-kontti pystyyn, mikä tekee sen.
Niin ja siis tässäkin...
Siinä alkaa tulla jossain vaiheessa
siinä tulee jo overheadia. Kyllä se pitää sillä mallilla tehdä, että se yksi funktio voi suorittaa useammankin. Ja sitten siinä on niinku tietyn verran aikaa, nukkuma-aikaa ennen kuin se sitten timeouttaa ja menee pois. Juu, toimii. Kyllä. Toki saattaa olla ihan pikkasen hienostuneempi kuin 124 riviä ihan vitu kauheet Node.js:ssä. Mut mä vähän niinku odotan. Toi oli just hyvä, siis toi IP-osoitteen selvittäminen on ihan oikea use case tässä niinku muutama päivä sitten yhdellä asiakkaalla. Niin oli vaan silleen, että täytyy saada sisäverkosta se IP selville. Niin ei voi käyttää ulkoisia palveluja. Sitten kuka on nopein pistää se hemmetin PHP jonnekin pystyy, että sieltä saa sen. Niin kyllä se niinku, ei kukaan sen tonneksi lähtenyt mitään Kubernetes manifesteja kirjoittaa. Tuo se olisikin ollut. Asia ollut, että palaillaan. Olisi se kyllä hieno silleen. Jos te olette lukenut joskus Circlesilla on mahtava blogipostaus siitä, että miten monimutkaiseksi tämä homma on mennyt. Serverless on kiva vastavoimista siihen.
Kai Docker Hubista löytyy valmis kontti, mikä kertoo sen IP.
Oh, I didn't mute.
Probably everybody was hearing.
Yeah.
See you again.
Try to share the presentation afterwards, so just in case you're interested.
Yeah.
That's the healthy Finn in you, see?
So yeah, then maybe let's get started. Let's see when the rest's gonna. Yeah, hi. So I hope you're not too tired yet. I try to walk you briefly through like how we did Kubernetes on AWS at Zalando. I'm Michael. I'm with Zalando now for roughly 1.5 years. Joined them first on the German office in Dortmund and moved to Helsinki beginning of the year. I'm working as a engineering lead at Zalando, leading a team of people working with like external integrations into the Zalando platform. And yeah, I'm a Java developer by heart, so always try to still get my hands dirty a little bit. And I've been always interested in doing some DevOps stuff. So yeah, I don't know how many of you know Zalando. Who has ordered at Zalando? Ah, good. Yeah, so we're Europe's leading fashion e-commerce platform, currently active in 50 markets. Well, kind of 21 million active customers, and then making quite some revenue, like having over 13,000 employees now. And when it comes to when it comes down to like a little bit more tech stuff, so we currently have like over 1,800 employees working in like tech-related jobs, software engineers, UX designers, and the like. We have offices in Berlin, tech hubs in Dublin, Helsinki, and Dortmund. We have over 100 different nations working here. I think the Helsinki office has by now 28 different nations working here. And yeah, as you might know, we're kind of looking to hire people. So just in case you're interested, and well, reach out, go to tech.zalando.com. There's quite some positions open. Yeah, maybe talking briefly about how we ended up considering Kubernetes and then how our journey was. So, well, in the beginning, we started with PHP. Then in 2010, when we aired our first TV commercial, we realized that the PHP solution did not scale, so we moved over to building our Java monolith based on Tomcat. This one's running in the data center. Built some custom tooling and the like, and then in 2015, when we kind of started that rapid scaling of the engineering teams, we moved over to building stuff based on microservices. Are currently in the process of moving away from the data centers, deploying all stuff on AWS. With the microservices, we moved already over to running Dockerized applications, so whatever we deploy on AWS is a Docker container. We use CloudFormation to spin up the stuff there. We do immutable deployments on AWS as well. And yeah, end of last year, we started shifting over to Kubernetes and then like kind of considering Kubernetes as the deployment infrastructure, again, on AWS, Docker as well. So that part was pretty easy moving forward. So when we talk about large scale at Zalando, I'm not going to talk about like running Kubernetes clusters with thousands of nodes. Large scale for us means like addressing those 1,800 different developers on like over 200 teams and the like, and how to get this done. So large scale for us means currently every of our engineering teams has at least one AWS account, which is currently like, I think it's even above the 255 active AWS accounts. So that's like kind of the scale we're operating in. And that's what we need to address on Kubernetes as well, like kind of find a solution on how to scale those infrastructure stuff. So as I said, like kind of we have like roughly 200 engineering teams. We're aiming for a final solution about having like 30 different clusters. This stops infrastructure is how we currently deploy stuff on AWS. So this is some tooling built around manifest like CloudFormation stuff and ensuring that people like that we can somehow have CloudTrail stuff when we deploy to AWS and the like. And yeah, as I said, like we already have like Dockerized applications. So one of the main goals was to have no manual operations for those Kubernetes clusters, just to make sure that we can actually run 30 of them in production. They obviously should be reliable because, well, if it goes down, we're going to lose money there. And when we're talking about 200 teams, they should be auto-scaling. So we don't want to have like DevOps teams scaling up and down clusters. And like migration should be seamless. But based on a Dockerized apps, that's quite easy to achieve. So if we're talking about different Kubernetes clusters, they really got to live totally separated. So there is no like VPC peering, no overlay stuff between those clusters. So no magic on a network level to make them work. They all talk to public internet and then are authenticated using OAuth2 credentials. That's stuff how we currently do it in our infrastructure as well. So we just needed to make sure that this also works on Kubernetes. And I'm going to come back to that a little bit later. So how our development team should interact with Kubernetes is pretty straightforward. We do not want to give them write access to production clusters, at least not for normal operations. So normal operations is you develop your code, you push it to GitHub Enterprise. This one triggers an automatic build and goes through our CI/CD pipeline. And this is the only way to get code deployed on production clusters. For obvious reasons, there is some emergency access. So in case like we have some live issues, you might want to look into the pods, but this should not be a normal operation. And on the clusters, we have our master nodes and the worker nodes, and those are basically based on auto-scaling groups. I think this part is quite straightforward, and we already saw this. So how does deployment work? Well, the part on top is straightforward Kubernetes manifests, the deployment for Kubernetes, building some credential stuff, defining an ingress, defining service stuff, and the delivery YAML is basically a pipeline description of the steps that need to be done to get the stuff from checking out the source code to deploying it on the cluster and switching traffic to active steps. So this is like proprietary configuration for the CI/CD pipeline. Yeah, that's a standard ingress YAML, Kubernetes straightforward. You just define your host and which path and to which application or to which service this should map, and then, well, Kubernetes does the magic, as we've seen in the first presentation. Yeah, this is currently our deployment or continuous delivery platform that has different steps where you can like kind of build the stuff first and then maybe deploy it to a staging cluster, deploy it to a production cluster. What we have in there is, for obvious reasons, you get like kind of output on what works, like standard build server stuff. We try to use like existing solutions for that part. So we started off with a Jenkins-based solution, which did not work out in terms of like addressing the requirements we had from making sure that we can have correct audit trails, that it scales with the clusters and the like. So that's when we decided to build our own continuous delivery platform tailored to our needs, and then making sure that it adheres to whatever we want to have there. For example, it has stuff like deploying stuff to production would need like manual approval, so someone will need to click the approve button. Now let's go to production. That's more or less kind of configurable on your deployment stuff. So for specific services, we want to have like real continuous deployment, getting it to production. But for like stuff that is not yet ready for continuous deployment, someone might want to just test the new deployment or make sure that it runs in staging and then enable it on production. Yeah. So as we're running on AWS, you heard that one of the main ideas for Kubernetes is to be cloud kind of provider agnostic. We realized it's not going to work for us. So our first idea was we go Docker, and then we can switch from AWS to Google and to Azure, and that's going to work like a charm. But yeah, in the end, if you be totally cloud or provider agnostic, then you lose all the benefits of that specific platform. So if you do not care about if you're running on AWS or on Google platform, well, there is no DynamoDB, there is no SQS, there is no RDS, because, well, this is provider login. There are no IAM roles, for example. So this is the part where it actually gets like provider specific. And we built this stuff in a way that it fits in totally into the standard Kubernetes deployment stuff. So in here you can like define your custom stuff like a IAM role or an RDS database, and it's just adding like deployment YAML files in there, and the rest is again standard Kubernetes stuff. So for example, in this like specification, this is a template as well, and you can say that, well, this specific containers should have access to a specific AWS IAM role, which means, for example, you can tell one specific pod or service that it has the right to access a private S3 bucket, for example, or that it can access the DynamoDB database. And all that stuff is taken care of our Kubernetes infrastructure. So the developers do not need to assign like any roles to any nodes on the cluster stuff. That's happening. All the magic is done when the stuff is deployed. Yeah, as I said, like cluster autoscaling. Well, we want to make sure that the cluster really autoscales. That means it should be able to fulfill all the resource requests that are coming in. So if on one of our production clusters, a new development or the delivery team decides, well, there is a new service, it should run on that cluster, and the cluster recognizes, well, I don't have enough nodes for that part, it should scale up. We built it in a way that it has at least one spare node per availability zone there, just in case one node dies. Failover works faster, and then we can scale out as fast as possible. There is no manual tweaking of any cluster in there, so it's all down to the autoscaling stuff. If we find any issues that it does not work as expected, we change the underlying configuration of the autoscaling and do no manual tweaking of the clusters, just to make sure that we have a common shared configuration for all our 30 production level clusters. Yeah, the part that was more challenging is not actually the scaling up, but the scaling down part. So in the beginning, the first version was quite easy to add new nodes, but those nodes just stayed there. So once you hit a spike, you got up to your maximum number of nodes, and they stayed there, and then that turned out to be quite expensive. So we wanted to make sure that it's really, really elastic, but in a way that it doesn't scale down too fast. So if you just have like a couple of those spikes coming in, you want to make sure that it not needs to scale like the whole way, because like starting a new node and getting it into the cluster takes any time between 2 to 15 minutes, depending on like the standard workload on AWS, and then when it's able to fulfill your request for getting a new instance. So far it's been mostly based on existing open source solutions or stuff that we could find out there. For our AIM integration, this is stuff we built custom in-house, beside the delivery platform, which we also built. So our standard idea is that your pod runs a service which needs to access a resource server, maybe a service from a different team on a different cluster. Therefore, it is like public internet, OAuth 2, authenticated. So first of all, if it would hit that endpoint, it would get a standard 401 unauthenticated stuff, because it needs to have the OAuth credentials in there. So how we do this is based on what we currently have on our previous architecture as well. So we have some mechanisms in place to share secrets and provision like OAuth credentials to all our different services. This is way easier now with Kubernetes than it was with the existing infrastructure. So for Kubernetes, it's pretty easy. You as a developer just define on a YAML file again, well, this service would like to get credentials for a specific, or would like get OAuth credentials with specific scopes. You put it into the Kubernetes API server. The kubelet queries the server, knows, well, I should provision specific OAuth credentials, and therefore talks to infrastructure services and then makes sure that it mounts your OAuth 2 Bira token in a path on the pod. What does that mean in the end? Well, if you would have a microservice based on Bash, you could run it as simple as that. So you just simply cat on the credentials pass that token secret, and this one can just go into the Bira of the OAuth 2 token. You call the other service, and it works, because the other service, again, gets the token, validates it against our OAuth infrastructure, and that's it. So from a developer perspective, you do not need to care about getting an access token, about using your refresh token to get the next access token if it expires, and like that's all handled by Kubernetes. So you just have to like cat the secret. And if you're, for example, running on Node.js, well, it's pretty easy as well. Build a library that always reads from that file, and it's up to date. So, well, we hit a couple of challenges on our way there. One of the biggest one was actually how to get started there. For us, how to get started was finding out how we want to run our Kubernetes on AWS. So we did some like survey on what's out there, and then in the end decided, we're a big company, so we're going to go with our custom infrastructure there, which is partially based on that we already had tooling for AWS and how to manage CloudFormation stacks and how to scale them and how to make sure they operate. So we've already had quite some experience on AWS and thought, well, we can easier learn the part of Kubernetes rather than see that we get the existing Kubernetes stuff to adhere to our requirements when it comes to compliance and the like. So in the end, it's pretty easy. We have a very simple API CRUD service there for the cluster registry. We have some manager that just sees if a new cluster is required or if cluster needs updates. And then in the end, our cluster lifecycle manager talks to the Kubernetes API server and applies the manifest after it actually created the CloudFormation stack for the auto-scaling groups based on our existing tooling. So this part is based on existing tooling, and then we just added the stuff to talk to the Kubernetes API server and say, oh, that stuff should be deployed there on the cluster when we spin it up. So this applying of manifests is, for example, mounting of our OAuth 2 credentials, making sure that the AWS integration is there and so forth. So our clusters persist of two CloudFormation stacks, one for the master and the worker stuff that auto scale. We obviously use etcd for the Kubernetes stuff. Our nodes run on standard container Linux stuff, and then like after we started that part of the cluster, we apply the manifests and deploy whatever we need in there to manage the stuff. Then our goal was really to make sure that we only talk to the Kubernetes API. So the idea was not to talk to the Kubernetes API and talk to AWS APIs and alike. And that's why we started to build an integration for managing our DNS records in Route 53. So this like mate was our first attempt, and then we moved over to external DNS, made it a little bit more generic. External DNS is now an official Kubernetes incubator project, so if you want to check it out and contribute there, we're happy to add that part. Like our ingress controller for AWS is open source as well, so I think it's one of the two like standard projects out there to use AWS ELBs for ingress. And yeah, we use the existing kube2im project for the AWS IAM integration. Our ingress stuff, pretty straightforward actually. Our ingress controller talks to the Kubernetes API server, and then based on what ingresses should be defined, it creates the ALBs at AWS, make sure that they get the correct SSL certificates assigned. So based on which host you define on your ingress stuff, sees if there is an existing ALB it can attach itself to. If there is none yet there, then it creates a new one. And internally on the worker nodes we use our in-house HTTP router skipper to actually route then the requests to the respective services. But that part is totally exchangeable. So if you want to have a different HTTP router on there, well, go for it. We just simply choose our existing solution because we know how to operate that one. So it can do cookie-based routing, it can do header-based routing, it can be path routing, so whatever. We just know how to run this at scale. So that's the main reason why we went for Skipper there. There's a couple of questions we asked ourselves when we get started. So do we want to go single availability zone or multiple of them? Well, we choose multiple for failover reasons, and why not? We did not go for cluster federation because we just believe it's not there yet to run at the scale we need it to run. For the overlay network, we go with Flanell because it's rock solid and there and it just works. For authentication and authorization, we rely on our existing OAuth infrastructure. So pretty straightforward. Call this as a webhook from the Kubernetes API server, just because, it's been there and it's integrated with any company-wide authorization system. I think if you already have a bigger company and you have single sign-on systems, then most probably you want to integrate those as well. Second challenge is obviously stability versus having the newest features in there. So what we do there when we update our clusters, you as a team can define what branch your cluster wants to live in. So if you're more on the cutting edge stuff, then you will go for the alpha branch, get in all the newest features as fast as possible, but the potential downside that it might break and it might impact your operations. If you're more stable, just make sure it really works, we don't need the newest features, then you go for the stable branch. And you can always we do this kind of cluster updates and get external stuff in, get the PRs ready to merge and then deploy them and basically move them through the different branches. And only once we know that stuff has been proved to work at our setting on the alpha branch, then we would move it on to the beta branch, and the same for beta over to stable branch. So that's basically making sure that we do not deploy the newest stuff to clusters that are really important for day-to-day operations. And if those clusters do not need that specific features, then why risk to break them? One of the biggest problems we encountered in terms of stability is that we hit the AWS rate limits. We actually did that twice. So we hit that problem with our external DNS or mate stuff and with the ingress controller. And the downside there is if you hit those rate limits, then you basically lock yourself out. Because you cannot make any more calls to the AWS APIs, and the cluster just stays in any unpredictable state because, well, some calls might go through and some not. Kubernetes itself has, the core itself causes quite a lot of those requests as well for EBS. That got better in recent versions. And well, we have some monitoring stuff running that also pulls a lot of AWS APIs to get information. So yes, that's one of the biggest pain points we still see with AWS, just making sure that we balance those API requests on a level that they do not impact production code. So luckily, if you're on enterprise support and you hit the stuff enough and you pay Amazon enough money, then at some point you kind of get some feedback on how many of API calls you can do, but still this is, if you plan to go to AWS, keep this in mind, you might eventually hit those rate limits. Yeah. What you definitely want to do is use the limit range on Kubernetes. If you haven't heard about it, just look it up on documentation, just to make sure that specific pods cannot actually kill the rest of your infrastructure by just demanding like whatever resources are available there. So we didn't do this in the beginning, and we had quite some of those deployments who killed the whole cluster. Yeah. Second challenge was how to onboard our developers. As you saw, like we have 200 teams, 1,800 engineers. As you saw in the first presentation, there is a huge amount of new concepts for Kubernetes, and to teach all of our developers with those new concepts, a lot of them maybe not caring too much about the low-level details, but still they should, because they are responsible for running that stuff, also in production. We tried to address this in a way that, well, there is a Kubernetes training internally that basically guides developers through what they need to do to get stuff running on the Kubernetes clusters. We have some documentation, part of it open source, available publicly, part of it internally. That one's definitely a ongoing effort to make it better and better over time. When we started our journey, we did Friday demos where we each and every Friday demoed new stuff we added to our offering there. So started from the very basic stuff of how to get the Kubernetes stuff on, like, well, now this new feature is ready. All those stuff are internally available to still kind of have a look at it and then learn like how to do continuous deployment there. And yeah, in the end, there is still like support channels. People ask a lot. The more and more teams that get onboarded on Kubernetes, the easier it is, because then you get this peer support. So in the beginning, it's been pretty hard. It's that infrastructure team answering all the support requests. Now a lot of the more experienced teams already help out, like the newcomers there. Yeah. User experience. As you might imagine, those developers, big amount of them, they kind of get demanding on what to expect. So that's what we needed to learn internally as well, like see all our platform offers as offers, like products we sell to internal customers, being our developers. So the decision on why we want to develop our own continuous delivery platform versus going with an existing solution like Jenkins or Travis is an ongoing effort to convince users what's the benefits versus the trade-offs. Again, like the different YAML files, and for them making sure that they understand the difference between what is a Kubernetes YAML file, because they already previously used CloudFormation-based YAML files, so just to make sure that they do not mix the concepts there, that this is clear. Yeah, what we encountered, especially in the beginning, is like having inconsistent states on the clusters. And as we saw that we do not want to give people write access to production clusters, so resolving those inconsistent states might not be up to the actual developer because they do not have write access to the cluster. So this is like kind of just making sure how we can manage that part. Turned out to be more complex than we initially estimated. Yeah, well, you might ask yourself why not go with the AWS ECS solution and then rather build our own. One of the main reasons was we saw more benefits on building our own solution versus using the existing one, especially when it comes to our integration in like AIM infrastructure and our OAuth infrastructure. Yeah, This is a project from one of my colleagues at Zalando, from Henning Jacobs, who basically drove most of our Kubernetes efforts, called KubeOps view. That's just gonna render you like how your cluster looks like. So those are the different, I think those are the two master nodes and the sort of worker nodes, and those green and red boxes are pods there. So the green ones are good, the red ones are dying. So you can just have a look, and this is printing the resources on there. It's a pretty cool tool. Just scales up to a specific size of the cluster after. I think it's based on SVG, if I remember correctly. So if it gets too big, then yeah, it just crashes your browser. Yeah, so that's basically it. There's a couple of links to stuff we do or we have there. So we try to have a lot of our documentation for running Kubernetes on AWS in production on GitHub or like read the docs. This is our ingress controller, the external DNS one. This is ongoing effort right now, our Postgres SQL operator, to make sure that we can deploy Postgres high availability clusters on Kubernetes and make sure that they run and scale and survive nodes going down and pods being terminated and the like. I think my colleague Jan is talking at PostgresConf later this year about like how we built that offering and why we believe this is even better than RDS from Amazon, and then what the benefits are there. Yeah, we share a couple of our cluster configurations on GitHub. And yeah, and again, Henning just compiled a list of organizations that are using Kubernetes on AWS, just in case you want to check it out. That's basically it. I still need to make sure that I get the permission to actually share those slides afterwards. That's still an ongoing challenge, but I'm pretty sure we're allowed to do so. Otherwise, just search, because those are pretty similar to stuff Henning already gave, so those presentation might already be available. Yeah, if there's any questions, feel free to ask. Otherwise, I hope it's been somehow interesting for you.
Well, you touched on a lot of points there, but when you moved over to a Kubernetes-based solution, what did you find the hardest?
I think the hardest was convincing our delivery teams to switch to yet another solution. And there is like, I think we have the two extremes of developers in there. So we have developers who do not really care about any of the operation stuff. So they just, for them, Kubernetes is maybe even too low level, because they just want to write their applications and somehow get them deployed and run them in production. And there are the other extreme of the developers who really would actually really like to have the bare metal access. So for them, even our old infrastructure offering was like abstracting too much. So this is like kind of trying to balance that out and what is the right abstraction level, and convincing delivery teams on why this is beneficial for them. Like this whole user experience, onboarding, getting started stuff for the teams and rolling this out really at scale is one of the biggest challenges we're still facing. And yeah, we still need to survive our first Black Friday on Kubernetes. So because it's kind of from scalability issues, one of the like biggest challenges we have ahead, making sure that this part of the operation can really scale under heavy workload, and then that we can manage it. And so we're not there yet that we are currently completely on Kubernetes. So I think it's only less than 10% of our services are currently running on Kubernetes. The rest is still either running on a data center or running on our old AWS Stoop stack. So currently we're basically running 3 different deployment stacks, which definitely is some challenge in making sure that you still have enough people who know each of the stack and can troubleshoot stuff there and make sure that we get the migration paths right. And yeah.
But your goal is to go all the way Kubernetes.
Let's put it that way. We still believe this is the way to go, if we can prove that it scales under the heavy load we expect on stuff like Black Friday. But we're quite confident that we can get there. Any further questions?
We tried how different cloud providers scale. I mean, like you have a good example of load, and you have a multi-zone data center, so you can easily try it repeatedly.
So Oh, can you just like if you try it on different?
Can you have you tried your example workloads on something except AWS, like on Google Cloud,
yeah, so
on Amazon? You have a good experience.
Okay.
With, like one of the clusters can be tried to run on somewhere.
Yeah, so the question was whether we tried it to run it on different cloud providers, like for example Google. No, we didn't. So like our first idea of when we moved to the cloud and to AWS was, well, we want to be able to move to a different provider, but from a pure commercial and business impact assessment, we just decided the effort we would need to put into place to run stuff on Google is just not worth the potential payoffs. So we just learned enough with Amazon, and then we kind of have good enough experience that it just doesn't pay out.
Yeah, I have one. I have this sort of hunch that because Kubernetes abstracts a lot of complexity away from you, that maybe bare metal is coming back a little bit. People might start running it on top of bare metal actually instead of cloud servers. So do you have an opinion on that? Like why use EC2 instances that are super expensive compared to, let's say, if you got some really cheap bare metal and just use Kubernetes to handle all the breaking servers?
Yeah, so the question was whether I have an opinion on
running Kubernetes on bare metal.
Yeah, running Kubernetes on bare metal.
Would be like really cheap,
yeah.
And you could buy like a huge ton of it.
Yeah, so I think for us the reason to stay with AWS is just the potential that it's fast and easy to scale out. For bare metal, we would normally have to buy the hardware because that's when you really get the benefits, and we're still in like kind of the part where we do not really have like, so if you look at Google, they have like a pretty stable workload for most of the stuff, so they know exactly like what they need. I think then the benefit of having your own hardware and your own data centers really kicks in. For us, it's still like we're still growing, so we're still growing in terms of engineers, in traffic, in revenue, and then monthly visits. So it's pretty hard for us to predict what type of hardware would need, and there we still see the benefits of AWS, of the elastic of the cloud.
But have you thought about like the idea of splitting with data? So for example, like confidential data on-prem and public front ends in Amazon.
Yeah, so the question is whether we thought about splitting data on confidential stuff, maybe on-prem, on the rest on AWS. Yes, we assess that stuff as well. Currently, as far as I know, we're confident enough that we still can have confidential data on AWS to some extent. There is a couple of data potentially when it comes to credit card information, but I'm not sure if we store this at AWS or if we can store it at AWS, but that's like not my part of expertise. Yeah.
I have a quick question on managing state. You mentioned that you use RDS and S3, and on the other hand, you had some incubator project for running Postgres on top of Kubernetes. Are you storing state on your Kubernetes cluster, or is that something that you?
So yeah, the question was whether we store state on our Kubernetes cluster as we like kind of have Postgres stuff and running RDS and S3. For the Postgres stuff, yes, we store state in there. About the details, I unfortunately don't have like the answer. I think going with RDS was just for most of the teams the easiest way, because it's just click it on the console and it spins up the stuff, and you do not have to care about the operations. On the other hand side, RDS is pretty expensive compared to our own database as a service offering, especially on like load. And I think we managed to grow our in-house solution to where it is even more efficient than RDS, so we can really do rolling updates with zero downtime on the Postgres clusters and the like. For S3, we mostly use it for really storing blobs of data most of the time. Good. If that's all, then thanks for your attention.
Last page.